Yes, let's have these few examples on linear inequalities. So we have this question says, which is larger? Which of them? Which can we consider to be larger? We have gone through the base of inequality, the symbols, the reverse inequality. Now let's put them to practice here. We have minus 8 plus this, minus 8, question 1. Minus 8 plus 21, that should be, if you remove 18, sorry, minus 18 plus 21. Remove 18 from 21, what do we have? Because we have 3, then it's less than, what is 3 minus 21? I'll be minus 18. 3 is positive, this is negative. So is 3 less than this? This is not true. So it is not true. 3 cannot be less than a negative number. A positive number cannot be less than this. So it is not true. Automatically 3 is greater. Good. Question 2. Is this greater than from here? 60. Let's see this greater minus. Is there any negative value? Automatically is not greater. It's not. This one is automatically greater than this because it's already negative value. 12 times 8 times, of course, minus 12 times 8, you have minus what? That's 96. This is greater. This is correct. 60 is greater because 60 is a positive value. This is a negative value. Of course, you should know, even 0 is greater than minus 10,000. Is greater than it because it is a positive value first, and it is not negative. Is the number at the center of the number line, or all these ones that are the extreme, is far greater than this. Let's go to the last question. Question 3. The question says, find the possible value of x that satisfies the inequality 8 plus 2x is greater than 3 plus 5x. What should we do first? We want to get the values of x, the value of x, then we now get the greatest integer. Yes, that's the possible value of x. We need to get the possible value. Let's see. Because from here is inequality. I'm going to get a range of values for x and will satisfy this equation. But now, let's just get it ready. Now pick one possible value of x. What do we do next? It's just like we are having equality sign there. Right? If we have equality sign in collect like terms, then you solve, right? The same application, the inequality sign will not change our question. It's still going to be what? Collection of like terms. How do we collect like terms here? I have 8 plus 3. Then, or since we are looking for x, let all our x variables be at the left hand side. So you don't have to stress yourself about having a reverse inequality. So we have 2x minus 5x is greater than 3. This comes here, we have minus 8. Then 2x minus 5x is what? It is minus 3x is greater than 3 minus 8 minus 5. Right? Now, what are we supposed to do here? We are looking for x, we should divide by the coefficient of x. So, divide by minus 3. That's the coefficient of x. So, we have minus 3x, 1 minus 3, greater than minus 5 divided by minus 3. Right? Now, this cancels this. The moment you divide through by a negative value, anytime you divide through by a negative value or you multiply through by any sign, what do? This inequality sign will change. That implies that x will now be less than. Because you divide through by a negative sign, it changes. This cancels this. That will become 5 upon 3. So x is less than what? One whole number, 2 over 3. Now, if x is less than one whole number, 2 upon 3, what is a possible value of x that we can have. Since x itself is less than one whole number, 2 over 3. Don't forget, 1 over 2 over 3 is like 1 point, this is 0.666. You keep your correct, right? So, 1.6, yes, your current decimal. So we have this. So, x should not be up to this 1.6. So the possible value or an integer that you can get for x, possible integer of x is equal to 1. Yes, I'm the 1. I'll not be 1. It is 1. So thank you for staying. Next video we're going to talk about more questions on this and how we can represent our questions on the number line. Thank you very much.